I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Hi. Professor Pi told me to help him, and I was supposed to set up this elimination stuff. And I know all about elimination. This here game's called musical chairs. And the music would play. I was real good at it in elementary school. The music would play and we'd dance around them chairs. And then when that music stopped, you had to hit a chair or get eliminated. I was never eliminated. I knocked people out of chairs all the time. That's what I know about elimination. You go round and round and then you ain't there no more because you've been eliminated. Thank you, Cowboy Rufus. That's certainly an example of elimination. Musical chairs. You dance around the chairs, the music stops, and somebody's eliminated. That is, they don't exist in the game anymore. But if you'd actually read the assignment I gave you yesterday, you would find out that I'm talking about elimination in algebra. Today, we're going to take equations. We're going to try and eliminate either the x or the y. If we eliminate the x or the y, you get one equation, one variable that looks just like the pre-algebra stuff you had, and we can solve that. That's what I meant by elimination. Obviously, if the only thing you got out of musical chairs was you didn't see my lesson yesterday. But this is solving by elimination. Algebra 2, REI B.3, REI A.2, and REI A.1. I can solve systems of equations by elimination. I can solve systems of linear equations algebraically. Somebody already thought that was algebraically or alphabetically. We're not going to solve them alphabetically. Read it right. Algebraically. There's two ways to solve them through algebra. The other day you did something called substitution. Today's the second type. We're going to call this elimination. I have up there 3 good videos. I will put the 4th one, mine, up there. If you don't get anything from mine, get in the other 3 videos, learn how to do elimination. In musical chairs, when the music stops, everybody gets a chair. There's a one-to-one correspondence there between people and chairs, except for there's one fewer chair. So we have a one-to-one correspondence that we learned about in chapter 1. It's a one-to-one function, except for the little boy here who's left out because he wasn't quick enough to find a chair. In mathematical elimination, we want to line up the x's and the y's and the constants. Usually I will do that in standard form, but as long as the x and the y and the constant are over each other, then we're going to try and add down and eliminate either the x or the y term. I always say add down. Some of my students are still using the word subtract. If you subtract all 3 terms, that's fine with me. I'm going to add down, so I'm going to multiply by -1 and then add down. I'm going to add them negative. If you're still subtracting, it's kind of the same thing. Here's my first example. The x's are under the x's, the y's are under y's, the constant terms are over there on the side underneath each other. And now all I do is add down. When I add down, what do I get? I get what do you get in the middle? The y's disappear, right? That's what I want. I want 1x plus 0y. And you're going, why do you put the 0y? I just want to show you it went to 0. Of course, you can leave out that stuff. And then I've got equal 3 when you add down. So I got x equal 3. I put my 3 in the point. It's an X, so you make sure it's first. I leave room for the Y that's coming. Now I got to go find the Y. How do I find the Y? Substitution. We did that the other day. I'm going to take the original equation. I'm going to substitute in the 3 for X. And I get 9 minus something is 5. The something obviously is Y equal 4. So my answer is 8, 4. Where'd the 8 come from? I told you, first thing you put in there was the 3. If you put the 3 in there and then go up, the only blank left is the 4. It's 3, 4. How do I know it's 3, 4? 3, 4 has to work in both equations. 9 minus 4 is 5. That one works. Minus 6 plus what? Plus 4 is minus 6 plus 4, negative 2. Yes, it is. So all I did was I lined them up and I added down. And since when there was 1 plus Y and 1 negative Y, the Y was eliminated. Sometimes they're not quite that easy. Let's look at my next example. I got minus 4Y, I'm sorry, I got 4X minus 3Y, and I got 4X plus 3Y. So when we add down, what do we get? We get 8X equals 64. Divide both sides by 8, and we get X equal 8. Put the 8 down here. Now I'm going to go find Y. How do I find the Y? Take the original equation. Take the original equation. Let's try this one. Put it over here. And we're going to put in 8 for X. And you all know how to do this, but you know, in Algebra 2, right after I get done with Algebra 2, I got Algebra 1, and they need to see all the steps. So yeah, I know, you're Algebra 2, and you can avoid all these steps. So that would be 32 minus 3 times something is equal to 29. And our something, of course, is 1. 32 minus 3 is 29. So let's go back and let's put the 1 there. Here's my next example. We need the coefficients of X and Y to match. We cannot have 6 take away 12 because that doesn't eliminate X. And we can't have minus 4Y plus 5Y because that doesn't eliminate X. It doesn't eliminate Y. We got to eliminate something. So take a look at your coefficients, and now you go back to 3rd grade with something called the least common denominator, or the greatest common multiple, or whatever you called that in 3rd grade, because you've forgotten. It's something that 4 goes into, something that 5 goes into. And that something would be like 20, right? So let's multiply the top line by 5, multiply the bottom line by 4, and that's what I get here. 5 times that. Now, I put it in parentheses because you got to remember, it's not 5 times 6. It's 5 times all 3 terms. So I come up with that equation. Then I multiply this line by 4, all 3 terms. If you don't do all 3 terms, you've messed it up. It's not going to come out. Now I take these two. When I take these two and add down, what do I get? I get 78X equal 78. So X is 1. Now I'm going to go find Y. When I find Y, I don't want to go up to this equation because it's not the original equation. Where'd that come from? It came from some algebra I did here. If you messed up the algebra here, then all you're checking is your wrong mistake. So I'm going to go up and get the original equation. Let's try this one. It doesn't matter which one because they're the same, because they're simultaneous, right? I bring that one down, and I'm going to put a 1 in for X. I substitute the x for 1, and I get 6 minus 4y equal 30. So 6 minus 4y equal 30. We are going to subtract 6 both sides. Yeah, I know you know this is algebra 2. You know that. But in algebra 1, I actually tell them that. So I get minus 4y equal 24. So 1y equal minus 6. I put minus 6 in there. Where'd the 1 come from? I don't know. I think I'm ahead of you. Because I haven't proven that x is 1 yet, have I? Oh, I did up here? Are you sure? Yeah, it says x is 1 up here. So I already had that 1 in here. That's why it's there. I put the 1 in for x and I'm waiting for y. Now I'm done. Where do they cross? They cross at 1 minus 6. If you had this problem and you were graphing it, like we did the other day, they would cross at 1 minus 6. What did I do? I lined them up, I added down, and I tried to eliminate either the x or the y. Could I have done it a different way? Let's go back to this example. Could I have done it a different way? Right there. Could I have done that different? I got a like denominator. That's not denominator. What is it? It's not like denominator, but what's 4 minus 4 and 5? What do they go into? Okay, it's like a like denominator. It's my least common multiple. It's the smallest number I can think of that 4 and 5 went into. Could we have multiplied this line by minus 2? What would happen if we did that? Would we get a negative 12 over a plus 12? Yeah, if we did that, we could have solved the same equation. We would have solved for y. What do you think y would come out? See, I think y would come out minus 6. Then we would go back and get the 1. That's how we're going to do elimination. Line them up on top of each other, get them to cancel out. We want one negative coefficient above one positive coefficient. When we add down, we get nothing. And now there are 2 cases when you eliminate that you might have a problem with. Let me show you the last 2 examples. Let's say we eliminate, and this is what we get. 5 equal 9. If you eliminate both the x and the y, and you get 5 equal 9, when is 5 equal to 9? Yeah, I know, never. But I wanted to show you the example. This would be no solutions. 5 is never equal to 9, no solutions. If you eliminate everything and you get 5 equal 5, it's all solutions. What you're looking at are 2 coinciding lines. They're on top of each other. They look like one line, but they're actually 2 lines. If you eliminate everything and you get 5 equal 5, that's great. It means all solutions because you've got the same 2 lines and you eliminated the entire line. Now, those are 2 trick examples you might come up with. The rest of these, you should be able to come up with some whole numbers today because I didn't deal with fractions yet. We will in a couple of days. Hi, I think I understand that elimination, Professor Pi. I just want to know how come algebra ain't as much fun as I had in musical chairs in elementary school. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.